Well, I've been through the transistors and checked everything, and they all looked okay. And I was a bit confused that I'm still getting this clipping effect. Let me just show you when I run it on the high voltage output mode, which is the 10 volts, which actually basically enables another amplifier and disconnects a attenuator. And when, if you see here, let me just reduce the frequency so you can see what's going on. You still suffer from this rather annoying sort of clipping, where it looked like it, if you pushed it one way, it would clip on the output. You know, that the whole signal would be squashed off. Now let me just show you this. This is on the 10 volt range that I'm talking about. We've adjusted offset. Push it up. You see, it crimps. This isn't attenuated. This isn't the output attenuated. That's pushing it, trying to push it positive. The scope's DC coupled. Negative. It allows the bottom to fall away, but it won't allow it to go positive. I went through everything and I couldn't find any transistors that are faulty. Basically, this is out on the output of the amplifier, so it's an amplifier problem. So I've been through it all and I couldn't work out what it was. So I went through the manual and it didn't really specify anything about problems with DC offsets or anything. And then I thought, well, I did notice on the generator, you probably can't see it, but it says impedance of 50 ohms. It doesn't actually say that on the 10 volt setting, but I thought, well, let's put a 50 ohm terminator on it. When I put a 50 ohm terminator on, obviously we get the reduced level because it brings it down, so this should be 10 volts peak to peak. We're on the 5 volts per division at the moment. Triggering is a bit off. Okay. We got a just over 10 volts peak to peak. We can adjust that with the vernier, obviously, control. So let's try it now. And if I adjust the negative offset there, it goes fine. Now I go positive, and it's fine. So it looks to me that that DC offset control will only work if the unit's terminated with the 50 ohms, and it sort of makes sense really, because the output stage was didn't look like it was a bit quite a crude sort of mechanism really. When you turn on this 10 volt range, it basically couples up a couple of transistors in parallel, and they're open the collector output straight to the output of this unit. So there is a bit of sort of matching and stuff, but there isn't a lot in the way of sort of proper sort of buffering or anything like that. So it basically means if you short that output out when you're in the 10 volt range, you'll take those transistors out. And I think that's a lot of the problem with the units on the internet. On eBay and things that you buy, they are damaged from that sort of thing. Now it all looks like it's working all right, so I think basically it's sort of really wrapped up. It's a bit confusing how to operate. We've got a delay button, a duration button. So basically duration is your duty cycle. And then you can see that if you adjust that, you adjust the duty cycle, the pots are still a little bit noisy, they probably need cleaning, but it's not going to be something I use particularly often, but it's nice to have something that produces a nice square wave. And delay circuit is basically, it's a bit confusing really actually. You'd expect a sort of like a base frequency, your duty cycle maybe, and your off cycle, and then you've got a ramp adjustment here, which this is quite useful. And basically you need to keep that, if you want a clean square wave, you just turn that to the lowest setting it will go, and that basically adjusts the it's not easy to see on here on the scope, and certainly not on the camera, but what it does is adjust the ramp of the signal, so you can actually produce other signals from adjusting the rise time and fall time, so you can actually produce like triangle waves and things. I got some earlier on, but there you go. You can see the effect of the waveform on there. Let's just try. So you can see you can adjust. That's the fall time. Obviously, I'm adjusting. The scope's triggered on the fall time. Let's try and trigger on the rise time. And so we've got two adjustments here. There's your rise time adjustment. So you can actually adjust and get quite sort of elaborate sort of patterns and things like that. And you've got control on the bottom of the generator as well that will allow you to adjust duty cycle, number of pulses per actuation sort of thing. So you've got single, double, or divided by 2. So it's I mean, it's not gonna be a piece of equipment I use that often, to be honest with you. But it was cheap. And it was an interesting project to have a tinker around with, and it might be useful for someone who's sort of doing a bit of sort of starting out in computer logic and stuff like that, or the early sort of low frequency stuff. But yeah, that sort of basically sums that generator up. Working now, and not particularly useful, but an interesting another interesting Philips piece of test equipment. That I quite like the Philips stuff, actually. I must admit, it seems to be pretty reliable. Anyway, thanks for watching.